Recording in progress.
Video is going to cover the test review. We have the test on Wednesday. So I'm going to do sections 1 through 4 of chapter 1 today, and then in class on Tuesday, we'll finish 5 through 7 before we take the test. So on the test review guide, section 1 involves sets, set notation, and Venn diagrams. So in this case, we have 3 different sets. We have set U, where X is a digit. We have set A with 0, 2, 4, and 6, and then we have B. And just as a reminder, so the way this is written, this is called set builder notation. My writing is funny because I can't, if I put my hand down on it, it freaks out. So I'm just trying here. And then A and B are both written in list notation. So we would read that set builder notation as set U is equal to X, where X is a digit. Now, we have to be careful with this verbiage. A digit means it's a number that is comprised of a single digit. And in this case, I would keep it as, really, it should say a positive digit. So that means that set U, our universal set, contains oh, that was awful. Let's try that again. The elements of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. So I'm going to start with the Venn diagram because I actually like the Venn diagram and then use that for our various questions about these sets. So U is our universal set, and then we have set A and we have set B. Now we always start in the middle. So start with the section where U, A, and B all converge. So that's our union of these 3 sets. So I know that A and B both share the elements 2 and they share the elements 4. So that goes in the middle part here. 2 and 4 are the intersection of A and B. And then A contains 0 and 6, and B contains 1, 3, and 5. So now I'm going to go ahead and place the elements of the universal set outside of A and B. So we know I have 0, 1, 2, 3, 4, 5, 6. So I'm just going to kind of spread them out here. 7, 8, and 9 are elements of our universal set that do not exist as part of set A or set B. So now we can do these. So just as a reminder, I think of this, and I mentioned it in class. Those of you that drive, it might be helpful. But this, it kind of looks like the U-turn sign. And so if you think of it, when you can do a U-turn, you can only do a U-turn really at an intersection, typically, whether or not there's a red light or a stop sign. But those will sometimes help. So this is an intersection. And we also think of this as an let's see, and statement. So it's for all the elements that are in A and in B. For union, again, it looks like a U, so that's our union. This is more of an or statement. So this is anything that is in set A or set B, all go into the set that union creates. So, and then of course, let's go this next one. We also have it's like a prime. I cannot make it straight. Maybe it's my internet connection. But that little, it's almost like an apostrophe. The prime symbol means complement. So it's anything that is not in this case, not in set A. So you could kind of think of it as opposite, or you could think of it as not. So anything not in set A would be A prime. Anything not in set B is B prime. All right, so going back to number 1, A intersection B means that we are only looking for those elements that exist in both A and B. So that's our middle part. So that is a set containing the elements 2 and 4. And then A union B includes all the elements in A or B. So that's the 0, 1, 2, 3, 4, 5, 6. Okay, so set notation 1, 2, 3, 4, 5, and 6. All right, the complement of A is everything in the universal set or in B that is not in A. And I did this, that Probably not. Try. Okay, so I'm gonna highlight set A because those are all elements in set A, and that allows me to see all the elements that are not in A. And so that tells us we have a set that contains 1, 3, 5, 7, 8, 9. That's the set there. All right, let me reset. So 4 includes the union of A and B, which I already have in number 2 here. So that is the 0, 1, 2, 3, 4, 5, 6. And then I need B, I have B prime, or the complement of B. So I'm going to go ahead and define that if I can get my pen to work. There we go. B prime. So that's everything not in B. So I'm going to highlight B, or try to stay in the lines here. And so that means that's 0, 6, 7, 8, and 9. All right, so if I want the intersection of the A union B and B prime, then I need to look up here. So it looks like I have, let's see, it's all, so it should be everything in A, right? So, but if you look at the sets, you could see it. We have a 0 in both, we have a 6 in both, and I think that's it. So 0 and 6 is the intersection of A union B and B prime. So it's everything in A that's not in the other two. All right. So if we look at 5, 5 has A, which is the 0, 6, 2, and 4, intersected with B prime. So what it's asking is that anything in A that is also in B prime, and that is, again, the 0 and the 6. So this is just sort of an example to show you that you can have it written 2 different ways, and you'll end up with the same set. All right, let's move on into section 1.2. 1.2 covered kind of the basic building blocks of geometry. So what are the 3 undefined terms in geometry? They are the point, the line, and the plane. So we can't define them. We can only describe them. So a point, we can call it it's a single location in space with no width or thickness, a dot or a location. We illustrate that. We draw a point and we label it. I'm going to name this one P. So we notate points with a capital letter. So this is P. And then to distinguish between set P or point P, we do have to write point P in front of it. And that's how we notate it. Capital letter, and we would say point. All right, with a line, so a line is, let's see, I would say a set of points going in opposite, well, we need to say that straight. So maybe bring in a straight dimension. I always spell this right. I-M-E-N. That's how I always spell that wrong. Something like that. So it's a set of points going in a straight one dimension, infinitely. So we would mark that. Now we illustrate that by putting the arrows on the end, and I'm going to add 2 points, A and B, so I can illustrate that this is a line. It only goes through 2 points, or at least in this case, and those points have to be collinear. And we notate a line as AB with the line symbol above it. We could also call it BA. trying. A pen is not wanting to work. You can also like name it for it. So this could also be line, in this case, line L. You may also see them written that way. All right, and a plane, again, is a set of points with, again, with no width, well, with no thickness. Width. In 2 dimensions. Weird. We notate that as like a parallelogram, and I'm going to place 3 non-collinear points, label those A, B, and C. And we can also put a little lowercase p in there. A plane can have its own letter, and in this case, it's a lowercase p. And so that denotes that we have a plane. And we can either call it plane A, B, C, or plane P. Okay. All right. So also in section 1.2, we talked about the 5 main characteristics of a good definition, that it is accurate, concise, objective, reversible, and understandable. So this first one, a frog is not an amphibian. So with accuracy is more important in regarding the words that are used, and we'll get to that in a second. In this case, they are specific about whether it's a frog or an amphibian. But in this case, this is an example of it not being reversible, because we cannot, it's false that an amphibian is not a frog. That would also work if it was positive. If we said a frog is an amphibian, it didn't have that not in there, you could not say that an amphibian is a frog. So we would need more information in order to make it reversible. So in 14, a vector is a directed line segment. Now in this case, it's not understandable, and that specifically refers to the words used, because we do not know what it means for a line segment to be directed. So it's using terms that you would then have to turn around and look up in order to find the definition of the word that you're being told the definition of. So that is when you have a term that is not understandable. It needs to use language you've already been taught or you're understood to know. All right, for 15, we have an atheist is some crazy nut who denies that God exists. So this is an example of being not objective. So anytime you've got a personal opinion or emotional words, the connotation is either very positive or very negative. So, we would not say crazy nut. So we say an atheist is a person who denies that God exists. The fact that we've got words being used in there that add a lot of emotion or connotation to it means it's not objective. All right, 16, space is a set of all points. That is a perfectly good definition. We could also say that a set containing a set of all points is space. It's reversible. We know what a set means. We know what points are. So it's understandable, it's accurate, and it's concise. And of course, it's objective. So this one is no problems. Okay, a postulate is that thing that isn't proven. This is where we talk about not accurate. It's not using specific language so that you know exactly what's being talked about. So this is an example of not accurate. Okay, 18, our last one. A trowel is a small handheld shovel for digging in the garden. Now, this is a great example of being not concise, because small and handheld mean the same thing. So eliminate, and I will use handheld, it's a little more specific. So you could say a trowel is a handheld shovel for digging in the garden. By telling me it's handheld, you are implying it's educated implication that it is also a small shovel. So this one is simply not concise. All right, so let's move on to look again using these set operations with rays, and also I want to kind of review some of the notation. So we notate a ray with a straight line segment with an arrow on one end. So that shows that we have an origin. It also shows that the origin is included in the set, which makes it different from a half line. So a half line, you need the origin to know where it starts, but the origin is not included in the half line. It's every point beyond that. So we have to put a little circle, open circle on one end, and then draw our arrow from that. We also have a line segment. So whenever we have a line segment, we use a straight line. That looks really weird. So I'm going to use the letters AB. So a straight line over AB means that is a line segment. It has an ending and a beginning. And then, of course, the last one is a line. Whenever we mark a line, it has the arrows on both ends to show that it's going in both directions infinitely. All right, so let's look at these. So what we're looking at here is this is ray AC intersected with ray BD. So I'm going to draw this. So the first letter is very important with rays and half lines and line segments. Well, mostly rays and half lines because we need to know where they start. So in this case, it starts at A and goes in this direction towards C all the way to the end because it's infinite. And then we have BD. So it starts at B, but then it does go in the same direction. So we are going to have some sort of intersection. It's going to start at B. And then intersection, of course, means it has to be in both. It's an and statement. So B is going to be our origin. And since both of them go infinitely, you could either say BC and have the ray symbol above it, or BD, because we have two different points on the right side of B, and both of them would go infinitely. So either answer would be acceptable. All right, so AC, I should have kept that. So I've got ray AC this way and ray DC. So I'm going to start D, but DC, because I started D, it's actually going in the opposite direction. And this is an intersection, so we need all points that are in a ray AC and in BD. So they're going to start at A, they're going to end at D. See? And so we have a line segment, we have a beginning and an end. So AD is our line segment. That any points that exist between those two and those two endpoints are going to be included in the intersection. All right, AC again. And now we have BD, but it's a half line, so we start at B, but it doesn't include it. And then it's going in the same direction. So now we want the union of these two. Well, the union is one and the other, so it does include all the points from A to B. It includes B because that exists on a ray AC, and it includes everything past that. So that means that ray AC is the union of these two. Okay, on to 4. So 4 has ray CA, so we start at C, but now we're going left in the direction of A. And then we have a line segment AB. So it's A, it's B, in between. And we want the intersection. Well, it should be pretty obvious. So the intersection is that line segment because it exists inside the set of ray CA. So that means that AB, our line segment AB, is our intersection. All right, the last one here, we have BD. So it's a line segment BD. And we have CD as a ray. All right, so in this case, again, it's a union, so we can have everything in one or the other. So that means that all of the points from B to C are included in our set. And then, of course, we've got an intersection right here from C to D, but then because it's a union, it also includes all of the points past D on the right. Therefore, the union of these two is ray BD, because it starts at B and then goes infinitely to the right. Or we could also write that as BC. Either way, same thing. Okay, just a little bit more. Okay, so in this case, we're talking again about the different parts. So there's three separate parts to a plane with a diagonal, which is just the line, that runs through it. You have the line, the diagonal, which in this case is not a line CB. This is also called the edge. All the points that exist on that line are their own separate set. And then we also have the two half planes. I'm not going to have enough room. So those are S1, or I guess maybe side one, and S2. So those are the three different sets that exist on this plane. And I apologize, this K is actually the name. I didn't move it right. The K is a line, another name for the line. So it's either line BC or you could say line K. But that's why that K is just lowercase k is hanging out in there. All right, so we know that, again, you can think of this as it's like a parking lot with a fence running through it. So you've got the fence, you can't be on the fence and in the parking lot at the same time. So you have all of the points on the fence, or in this case, the line. You have all the points on one side of the fence, all the parking spaces in place you can stand, and then you have all the points on the other side. So those, you would think of it as those three different sets. So when we're talking about the union, and the intersection of these different sets, that's what we're looking at. Now, we can see that set A, or point A exists in half plane S1, point D is in half plane S2, and C and B are both collinear points that exist on our diagonal on line K. All right, so S1, it's asking for the intersection of S1 and K. Well, I just got done saying there is no element, no point that can be on the line and in a half plane. So this is our null set. There are none. So null set, empty set, however you want to write it. All right, so this is asking for the complement of half plane S1, the union of half plane S1 and S2. Well, there's all the points in S1, which is kind of to the top left of our diagonal, and then there's all the points in S2, which is bottom right. So that means that the only thing that's left that's not in those two is line K, or line, you can also say CB or BC, but we're talking about the edge here. Okay, and also if we have the union of S2, so this section here, and line K, and then we want the complement, the only other thing left is half line S1. Sorry, half plane. I keep doing that. Half plane S1. All right, so 9 is just asking what elements are a subset of S1, which is sort of bad writing because an element can't be a subset. I guess we can think of it as elements in the subset S1, but we're just asking for, oops, A is the only point that exists, the only element in S1 that we know of, so that's just A. And then we're asking for the union between the two half planes and the line, S1 union S2 union K. Well, that's the whole plane, so that's just plane P. It's the whole thing. And then it's asking what elements exist are in the subset K, and that is C. We should put that BC. So that's all we did today on Monday. Is we covered 1 through 4. We'll finish the rest of them tomorrow. Anybody not here, if I send you the link to the video, I will also send you this document if you're able to print it. If you're not, that's fine. I've got it. I've got you one printed already in my room, so we can get you caught up then. Thanks, guys. See you later.